Good morning, ladies and gentlemen. Welcome to the World Foil Conference. Before we begin presentation, I would like to make a few announcements. I would like to give you information about your chance to win a WRC Lally of your choice in 2019. You can scan the QR code that you can see on the seating area, or the QR code will be shown later in the presentation as well, or you can go visit the website automechanika2018.wolfoil.com to enter your voice and let us know your vision of the future, and you might have a chance to win a great prize. And if you haven't been able to do so, I would like to give you a quick tour of what Wolfoil prepared for us today. And they have a great new concept of the smart oil cabin, and you will get to know more about your product through smart digital way. And there is a new virtual reality. You can take a virtual plant tour. So if you haven't been able to do so before this time, hope you will get to walk around and enjoy and get to know more about the Wolfoil and its company and product. So now I would like to introduce today's first speaker. We'll be talking about the development and latest development of the lubricant. And we have two true experts this morning. And the first speaker is the head of division 6.3 microtribology and wear protection at BAM. He has more than 32 years of experience in R&D of ceramics composite, thin film coatings, and thermal spray coatings, abrasive wear, as well as lubricant formulation, environmentally acceptable lubricants, and in trivial testing, including the dissemination into industry applications, more than 270 publications, and 51 priority patent field. So there's anyone better to listen to what and he's happy to share what the latest lubricant technologies. So let me introduce you to today's first speaker, the head of the tribology and wear protection at Federal Institute and Materials Research and Testing, Mathias Woydt. Please give a warm welcome to Mr. Mathias.
Ladies and gentlemen, it's not working. Huh? Here you go. So ladies and gentlemen, welcome to Automechanika and also Wolfoil. And the main question, which you will see now in the second slide, is the question, should we stop working on lubricants? Does Wolfoil have a future? This is a key question because everyone in the last years talks about e-mobility. E-mobility will be the future, maybe. And if you take data from the International Energy Agency, today we have roughly 3 million vehicles, 3 billion electrical vehicles. The prognostic is it will grow to, let's say, 300 million in more than 20 years. But we have produced 100 million of vehicles last year. This is the annual global production. Probably this year again 100 million vehicles. Then you must know that the global average motorization is 18%. We have in Europe 58%. So you can imagine it will double. Double of what? We have now globally a fleet of 1.3 billion of vehicles having combustion engines with lubricants. It will double. You have 2.6 minus 300 million of electrical vehicles is a big growth. So one thing is clear, lubricants, engine oils, gear oils have in any case a future. Even e-mobility will increase the market share. This means I can now continue. No? Still not working? The e-mobility has also some risks nobody is aware. Here you So here you have the plot of the lithium price and here of the cobalt price since 2000. And you see cobalt is volatile, and from 16 to now the cobalt price times 4 to 5. So it means the cost for a battery, the resource cost, is difficult. Same for lithium. Another problem, lithium batteries are, if you fly, you hear the announcement, pay attention of your mobile phone, but this is also a problem for vehicles. So you have now special safety labels for lithium batteries. The other point is, will the price go down? Probably not, because only 2% of cobalt is primary production. 98% is bypass production. You cannot increase this production. The other problem of cobalt is toxicity. Cancerogenic, mutagenic, and fertilizing. These are threats if you in the future want to have batteries based on cobalt and lithium. Toxicology, safety, prices. There may be a future, cobalt-free, based on niobium. Here you have the advantage, it's cobalt-free, you have a high power density, fast charging, a lot of cycles, but not before 2026. So there is a lot of time to wait until this technology is suited for mass production. Next slide. No? Okay. The problem you have is CO2. If you are a car maker, you have a CO2 problem because the limits continuously decrease. How we can meet these CO2 targets? First point is reduction in friction. And this can achieve by low or ultra low viscosity base oils, lightweight design, increase in lifetime and wear protection, and also waste heat recovery, because 40% of the heat of the fuel goes into the exhaust. You could recover. Another problem you have are emission targets related to the engine oil, sulfur, ash and phosphorus. And maybe in the future you will also have ecological targets like a content of renewables, biodegradation and toxicity. So if we compare now the contribution of a lubricant, of an engine oil, or lightweight car body design, if you want to have 3 to 5% of fuel economy, we have today in Europe an average of 118 gram per CO2, means you can save 0.15, 0.25 liter per 100 kilometer. To have a similar figure, you must put out of a car body 100 kilogram to have a similar saving. But fuel is not important for the legislation, it is always CO2 saving. So you can only save 3.5 to 6 gram if we have such a fuel economy improvement, which would be big. Same for car body, but to put out 100 kilogram of a vehicle means for the OEM 300 to 800 euro per car. for the additional OEM invest for a lubricant, alternative lubricant, is maybe 20 to 35 euro per filling for the factory fill. So it means that the engine oil and the gear oil or lubricating technology is an easy and economic way for the future to reduce fuel consumption. Heat recovery. You see here the example of a BMW 5 Series, the underfloor. So you put a steam generator into the exhaust system. The steam goes into such an expander, including generator, and you can save or recover energy from the waste heat. But the good news is, you have a lot of mechanical parts. You must lubricate. You need lubricants for the pistons, for the swash plate, for the bearings. So even such a technology of waste heat recovery using hot steam is a future market for lubricants. So why working on an engine oil? And you must share the three main groups. The piston group roughly gives 50% of the friction of an engine. You have sliding contacts. Crankshaft, roughly 25% of the engine friction, you have sliding contacts. Valve train, also 25%, but here you have a slip rolling contact with high contact stresses. You have here a lot of engines, and you can see the difference between sliding and slip rolling contacts. So the following is now divided. Here you see in a vehicle different slip rolling contacts, like a differential, cam, side shafts, and so on. Those driver systems run under 1,000, 2,000 or 3,000 megapascal of contact stress. So when we now want to reduce or to improve fuel economy, to reduce CO2 emissions, it is clear you reduce friction. You can have lightweight design, new alloys. You increase the load carrying capacity, you can reduce the size and the weight. You reduce maintenance costs, also longer service intervals. And basically here you have three options. You need new alloys, coatings, or new lubricants like polyglycols, esters, modified minerals and additives. For the steels, you need new steels. This is not related to lubricants, but this is related to the OEM. This can be related to OEM and supplier. Most people know the diamond-like carbon coating, but there are also other coatings which can be used to reduce friction and to increase load carrying capacity. So you see here now what happened. This is a slip rolling system. You have two discs with 10% of slip. They run under 1.5 gigapascal or 2.2 gigapascal as maximum contact stress. You have different alloys. This is a classic ball bearing steel. This is a gear steel, classic gear steel. You see the friction for them is quite high. At the end, 0.08. Now with new alternative steels, not changing the lubricant, only a different steel, you can reduce from 0.08 to 0.05. But these are available, but new alloys for the automotive industry. Second option, you have here the rolling contact. Now you make thin film coatings. This is uncoated. You have 0.08, let's say. Now you coat one surface, and now you coat both surfaces. So you can go down to 0.04, let's say. You can reduce by 50% just changing the coating or the alloy. Here you see the best performing coatings. Can be zirconium carbide, DLC, or a diamond coating. So you can reduce by 50% friction. The other question is now, what can do lubricants? Here you have a modified polyglycol. This is not used today as lubricant, but was used in the past, in the Second World War, in Formula One. And here you see how additives can impact on friction. Oh yeah. Here you see the reference. We have 0.09 friction. And now you give some additives, all different additives, into this oil. And suddenly you go down to 0.04, 0.04. So it means, by chemistry, what is important for lubricants, you can reduce friction also. It means, for the development, it's a toolbox. You can say, okay, I take new alloys, I coat, I take new additives. This is a hydrocarbon, a factory fill, engine oil, long life. And here you have the same. You start here, 0.08, 09. And with the right chemistry, you go down to 0.03. So you can significantly reduce friction. Now, the same question for gear oil, for gear steel. 20 Mancro 5 is a typical gear steel used. And when you have this alloy with different metallurgical conditions, friction is quite high. And now you take today used molybdenum dithiocarboate. You can slightly reduce friction. And now you use non-toxic bismuth. Ladies may know the bismuth because it's the gloss in the lipstick. Yeah, so it's a heavy metal, but it's non-toxic. You take different bismuth compounds, and then you can reduce significantly friction in a gear oil. The question is now, what happens when you combine metallurgy and additives? Here we start uncoated. Now we put the coating, friction down, and now coating and chemistry, we can still go down quite low, 0.03. So this is a toolbox to reduce friction, but you have different responsibilities. In a management-friendly summary, if you put all together, here you have the wear rate, here you have the friction. If you compare all together, of course you have an average and you have a range. So it means when we start with uncoated steels, you can, if you have the right steel, go down in friction. But you can have the same effect with coating one part or with both. But you see, the safest is to have both coated because the range is the smallest. Same for wear. You can find alternative steels with very, very low wear uncoated. Now you coat, wear goes down. and when you could both zero wear. This was now for gears and for slip rolling contacts. The other two main turbo systems, the piston group, you have 50% of the friction, and the crankshaft, 25%. All sliding contacts. And the point is, what happened when you reduce viscosity? Here you have the high temperature, high shear viscosity, and now you go down, and here you see the fuel economy improvement for truck engines, 6.7 liter or 12.1 liter truck diesel engine, and you see you have a fuel economy increase in this line. Now you change to a polyglycol, it's a new chemistry. You have the same trend, but you have a shift coming from the chemistry. So it means having lower viscosity oils reduces friction, increases fuel economy. And if you go here around, you see now SAE 0W8, 12, 16, very low viscosity engine oils, and the reason is you reduce friction and you improve fuel economy. Here you see the sheen. These are blending studies. You have here the kinematic viscosity at 100 centigrade, and here's the high temperature, high shear. Maybe some know 0W20 oils. They are in this box. 16 are here, 12, 8, 4. To give you an idea what means 1.4. Water has at room temperature the viscosity of 1. And now, maybe in the near future, we will have engine oils which have at 150 centigrade a viscosity which is double of water. It means it's very, very thin, and this is very demanding for the formulation. One problem with low viscosity engine oils, you have here the NOAC evaporation, it's the physical evaporation, and here the high temperature, high shear viscosity, and what you see is, so lower the viscosity, suddenly the evaporation goes up. It means for normal engines there will be a limit. I would say 16, maybe 12 when you use polyglycols, because the PAGs, they have in average the lowest evaporation rate. So in consequence, if you want to go to very low viscosity engine oils, you cannot longer stay in hydrocarbons for normal engines, not for range extender, not for hybrid systems. A big problem in the oil development is because engine tests are expensive, the people use tribometers. It can be 4-ball, SRV, block on ring, and so on. And these tribometers only operate in a certain range. Here you see a schematic graph of the coefficient of friction versus viscosity, speed, and load. It is called Strybeck curve. When you start at low speed, you have high friction, it goes down, the film is formed, and then when you have the oil film, friction goes up. But those test machines only operate here at low speed. So it means all effects from viscosity are not taken into consideration, and I think this was a disadvantage, and maybe some development went into the wrong direction. Here you see real Strybeck curve of piston ring cylinder liners. So you need liner, cut it out from an engine. You have here a piston ring and you spin. You see at room temperature, the hydrodynamic friction is really high, and when you increase your oil temperature, friction goes down. That's why under city driving, cold start, you have high friction. But as said, the test equipment only work here. When you convert the friction into power, then you see that the same curve changed. This is a problem of this test equipment. We measure here. But here is a big friction as power. And this now you convert into a work. You take the whole surface below, and then you have a new figure to rank engine oils, but you have now the whole Striebeck curve. It means dry friction, mixed and boundary, and hydrodynamic. What does it mean for the oils? If you look to gray cast iron liner and piston ring coated with a chromium alumina coating, and here you have different types of oils: factory fill oils, hydrocarbon, polyglycols. The factory fill, the gray and the green, at room temperature, high friction. You take a polyglycol, you have much lower friction at room temperature. At high temperature, the differences are not so big, but there are some differences. So it means changing the chemistry, changing the viscosity reduces friction for the future, but these are new chemistries. Same for an aluminum liner. Aluminum silicon 17 kappa 4 is a typical aluminum liner, and here you see the same. At room temperature, high friction, and changing the chemistry, it goes down. But look here, this is a factory fill oil, quite high friction. Now, without changing the viscosity, you put an additive and suddenly friction is down. So it means you can use new base oils, low viscosity base oil, or chemistry to reduce friction. At 40 centigrade, at higher temperatures, you have always the same effect with this additive in hydrocarbon and in the polyglycol. Here you see the comparison between aluminum and gray cast iron, the factory fill oil without and with this additive. So it means it works for both. It is difficult to have a solution which only works for cast iron, for aluminum. It's good to have a solution which works in all types of cylinder liner concept. So you see here the red, you put the additive in, it goes down. Here's a big effect. The other point for the future is, apart the point of reducing friction, is the environment. In a country like United States or 30 years back in Germany, 40% of the lubricant sold went into the environment. Now in Germany we are at 20%. It means that you have, especially today for hydraulic oils, regulations which wants to have really or ultimate biodegradation. You have to meet 2 or 3 toxicity criteria and the content of renewables. This is not a technical requirement, this is an environmental requirement. And today you have in US, it's mandatory the vessel general permit. It's only for marine, okay. We have in Europe the eco-label. The third revision is weighted, but it's non-mandatory. We have the Blue Angel, and we have also OSPA. It's for exploration, oil and gas drilling, where aside the technical requirements, you have also environmentally requirements which have nothing to do with technical specification. So finally, you can say metallurgy and tribology offer different novel tools for meeting fuel economy targets. You have a toolbox composed of metallurgy, coating, additives, and base oils, which each promotes itself as an exclusively blessed way to assure fuel economy. I am sure, and it is likely, that you will need 2 or 3 of these bricks to generate a big fuel economy benefit, but this will then require team working between OEM, component producer, and formulator. Good alternative steel to commonly used bearing and gear steels and advanced steels, particularly at higher Hertzian contact pressure, as well as in comparison to nitrogen, alloyed steel and maraging steels are seen. You not need to develop. They are used in other industrial sectors already, but you must bring those into automotive industry. So basically, the future for the combustion engine and the lubricant industry to compete with e-mobility, for me it's easy, but you need a multidisciplinary co-engineering between different partners, what is not so easy, because they haven't done this in the past. That's why I say this is the most promising way, but people dislike changes. Another problem today is embargo, dual use, REACH, and toxicological requirements or legislations, because if you have an additive which works and you know in 5 years it will disappear due to REACH, it's not a good news. So it means when you start today a development, you must already from the beginning look if this metallurgy, this base oil, this additive will not enter into a conflict with embargo, dual use, REACH or toxicity. Yeah, this was a brief general overview about different possibilities, brick system to reduce friction, and I think it's obvious that lubrication is a good solution and lubrication has a big future.
Thank you, Mathias, for the presentation. So we would like to ask audience if you have any questions.
Hello. One of your slides you said that the cobalt technology will be introduced in 2026, rather than now we have some time.
Yes.
What is the major reason behind it? Why we are...
Upscaling. It is upscaling. It's a new technology. Toyota, Nissan and Toshiba, who works on that, will need this to have the volumes, the production lines and everything.
So are we certain about that by 2026 these technologies will be introduced and then will be going with the cobalt technology?
Yes. It could be a cobalt-free solution. What is, let's say, a hope for the e-mobility? So long they stick on cobalt, they have a cost issue, toxicity issue, and so on. And you have the problem in Congo with the children's work. Yeah.
Thank you for the question, and thank you very much for these presentations.
Thank you.
He will stay a little bit after the presentation, so if you have any questions afterwards, we you can also ask him a question later. So please feel for this morning.
Dank u wel.
And I'd like to introduce the second presentation.
Maar dat past voor u.
He's the general manager at F Consulting, Francois Van Dievoet. He has been a true expert when it comes to lubrications and lubricant industry and innovation, and has happened over
to change the slides.
Over the years. Backed by the chemical civil engineer degree and doctorate in science.
This one?
That's going next.
And that's back.
Okay.
As R&D manager, taking his first step in the lubricant industry. Ever since, he built up his career around lubricants for over 40 years. Since 2012, he is a general manager at F Consulting, providing scientific and technical advice to different companies in Europe. So please give a warm welcome to Dr. Francis.
Good morning, everybody. First, I would like to thank Volvo for giving the possibility to Mathias and myself to present today our vision of future mobility. Mathias took what was possible, in fact, by changing the metallurgy and changing the lubricant to help to reduce the CO2. This problem, of course, is coming from what we call the Dieselgate, in fact, and there have been a number of political decisions without, I would say, carefully looked at what that is implementing, in fact. So, but the fact is there is a number of regulations who will forbid diesel in certain cities from 220 to 30 and things like that. So there is an alternative to internal combustion engines today with the electric vehicles or the intermediate with the hybrid vehicle. But the question is, will that really happen at the level that the people are thinking? That's of course the question. Apart from the fact that the OEMs could work on metallurgy, the lubricant producer can work on improving the lubrication, reducing the consumption. There is in Europe what we call today an organization called Fuels Europe, and they include all the refiners who are acting in Europe. Before the name was Europia, and they just came together some months ago to discuss this, of course, subject, and they decided to try to produce a new fuel with very low hydrocarbons, and they have called that Project 2050. So it's also not for tomorrow morning, but they are looking for funding from the EEC, and we think they will work on it, and maybe they will come with a solution. So, in fact, what could be an alternative to internal combustion engines, so engines running with gasoline and with diesel? First of all, this is mainly concerning passenger cars and not heavy-duty vehicles. We are not really ready with heavy-duty vehicles and for transport vehicles with those technologies, but of course people are working on it. So, what we are concerned, I would say the world concerned, we are projects to work to products who fulfill the requirements that Mathias just explained to you. But we need to be prepared to an end of internal combustion engines if it happens. For the moment, the first step was to put on the market battery hybrid vehicles, BHV. Then the trend is to go to full electric, and there is another possibility to use a fuel with hydrogen. So you can use hydrogen in an internal combustion engine that has been done many years ago by by BMW, but you can also produce your hydrogen on board. That means that you have a fuel cell vehicle and that you produce your hydrogen yourself. Of course, hydrogen is an explosive gas, so it's dangerous to use. When we talk about hybrid vehicles, there are different techniques. On the side there you see that there are different possibilities. You can have an electric motor who drive a vehicle, and in the meantime an internal combustion engine who could charge the battery via an alternator or other solutions. You have systems who are working in parallel, connected to the transmission. You have series vehicles with parallel, a combination of the two solutions. But the big problem today, of course, is not only the cost of the battery itself, but of course the low kilometers that you can run on a hybrid vehicle today. Let's say something like 40-50 kilometers. We have also a system to disconnect the gearbox, that of course spare also fuel, and you can have 4 electrical engines, and each of them are driving a wheel, so it's a 4x4 vehicle that you can use in all type of terrains. And now we can see that because the battery, the voltage of the battery was quite low. Today we are going to 48 volt. All this, of course, the aim is to reduce the CO2 emissions. And that's why, due to this Dieselgate problem, the political people have taken those decisions. But of course, to solve the problem, the technical problem, time is important, and as we have seen, it is important that everybody works together to solve the problem, and we can work on the fuel, we can work on the lubricant, and also work on the engine itself, of course. But we go for low SAPS products, that's for sure, and we go for very, very low viscosity, because it's one of the best way to spare fuel. And those products will also include what we call today friction modifiers. There are different products on the market, but of course they must be carefully looked at, because an oil formulation is a combination of different chemistries. So it is not like that you put something in a lubricant and that it will help you. Hydrogen vehicles can be burnt. The problem is, of course, that hydrogen must be kept at very low temperature, minus 290 something. So you need a reservoir who is very strong and who can resist at very high pressures. Also, when you fill your tank with hydrogen, that must require a number of security reasons, because of course it is an explosive gas, and for instance the BMW Series 7 at the time had a number of sensors who was measuring the hydrogen content in the environment, and that was done absolutely automatically, and the car was on a precise site to be filled with this hydrogen. Today, there are only three companies producing cars who are arriving with pure hydrogen. It's Toyota, Honda, and Hyundai. One of the problems, for instance, is that if I take Belgium, there is one service station, a Total service station, who is an air liquide system, and who produce hydrogen, and you can fill your car. So that's only one. In France there is zero. So you see, it's a big problem. BMW is working on this problem, as I said, and in collaboration with Toyota. Of course they run, and the emissions are water and vapors. But an internal combustion engine running with hydrogen needs to be lubricated. That's a good news. But the other problem is that they produce some CO2, the lubricant. So it is not a zero emission. And that's one of the problems when you are running with this type of engines. If you run with a fuel cell engine, remember that the fuel cell engine was invented in 1838, so yes, that's a long time. And there, of course, you are using hydrogen who produce electricity, and the electricity moves the engine. And basically there are today two systems, with one is anode cathode system with hydrogen and nickel, and the other one is relatively new technology with the proton exchange membrane fuel cell. Do we need lubricants for those type of vehicles? Do we need lubricants for battery hybrid vehicles? Do we need a lubricant for a full electricity car? Of course, the intermediate step is today the progression of the hybrid vehicles. They are all using a small or sometimes a bigger one engine, and even if you take the BMW i3 for instance, or i7, you have an internal combustion engine that makes the people also more safe, because if you have a problem with your tank with empty, you can take a can with you and go to a service station. With your battery vehicle, you are there and you stop there. So people are afraid, of course, that that happens to them. Another problem, of course, is the turbo high pressure diesel direct injection gasoline engines, who are more and more predominant, and they also save a number of, they are less consuming fuels and things like that. They use particle filters. I'm talking about gasoline engines, of course. They use systems like positive crankcase ventilation of easy air, who put more stress on the lubricant. And the famous problem of low-speed pre-ignition is very well known with this kind of, mostly with the small engines, but also it's a general problem today because the stop and go, and to spare the fuel, the OEMs have decided to put the system on the car. When you are stopped before a red light, your engine stops also. So you have always stop and go, and that makes this problem. And you need, of course, a special combination of additives to resolve that. Also, some fuels today who are on the market, like the gasoline 85, cause problems due to the high alcohol content. And I could say the same for the diesel, contains around 5% of biodiesel, which brings a lot of problems. An electric engine also brings some conductivity problem, because you are there with electrical environment, and you must know that there have been some accidents also with the batteries. What is the future? Good question. I always said, what is a good question? A good question is when the question is better than the answer. And I don't know, and I think nobody knows exactly what will happen tomorrow, but we need to be ready with solutions. And in the worst scenario case where we go for full electric engines, let's say 2050 maybe, or maybe first, because who could imagine that companies like Kodak, Polaroid, or everything disappears due to new technologies? And you must be ready when something comes on the market, that if something happens, you are ready to answer to the customer problems. In any case, an electric engine needs some grease for the bearings. Of course, they are mainly fit for life. They use a transmission lubricant, The battery today use coolants. They first started with air cooling. That was not satisfactory. And I think that it was Tesla who started first with a coolant. Today, the coolant that is used is a coolant who is in fact antifreeze. But you must know that the battery gives its power. It needs minimum to be at 35-40 degrees. Above 60 degrees you start to be in danger, and at 90 degrees you can make an explosion. So you see that cooling of the battery is of major importance. So we are working with a number of people on what I call the single lubricant concept or coolant concept. Is a coolant who of course extract higher quantities of calories and who also could be used in the transmission. And the product will be also based, of course, on oil, on water, because nobody finds something better to cool than water. So there is a market for a combined product that will certainly be in place if the situation happens. There are other bearings in the system, they need greases, of course. Heavy duty, I just talked some weeks ago with an engineer from Cummins, and he told me that one of the subjects where they're working on was to replace some parts of the vehicle who was using the turbo, for instance, using exhaust gas. They tried to replace that by an electric turbo. There is one car existing on the market today. It was the V8 from Volkswagen, and they were using a turbocharger, the normal one, and also an electric turbo. But that was to compensate and to make a better equilibrium because turbo also you have a lot of energy which lost, and also brings a lot of problems of temperature and things like that. But we think that this segment will be later than the passenger cars. And you have a number of cities today in the world who are forbidden the entry of heavy trucks. So let's say something like above 3.5 tons are forbidden. So that's it. If somebody has questions about the future of our lubricant world, I will try to answer it the best possible, and if you have other questions for Mathias also. Thank you for your attention.
Thank you, Doctor, for the presentation. We have a few minutes for the questions. If you have any questions, please raise your hand. And questions this morning?
No, but when the presentation is good, there is no questions. That everybody knows. Thank you.
Thank you so much.
Thanks everybody.
So he will stay a little bit afterwards, so if you like to
Sure.
enjoy the drinks,
I give you that back.
please feel free to enjoy. I'd like to also give you an
Thank you very much.
information